squared plus by 11 point. And then square root the whole thing is 11.73. Yep. So your stress max is equal to 11.21 or 121 times 10 to the power 3 plus by 11.730 times 10 to the power 3. So this will be equal to 11.121 power 3 by 11.730 power 3 is equal to 22.851 times 10 to the power 3 psi. Okay. So we also know that our tau max. So now our argument why we pick this is also very important. Okay, so you have to also check the normal stress and also the shear stress. Okay, so we know that this is less than the stress allowable, so it's good. And this over here is also less than your what? Less than your shear allowable. And the shear allowable in the question is given as what? Is given as 14.5. And this one is 24. And both in what? Both in PSI. So this is a very good question, especially now you know about 3D Mohs circle. Okay. Especially now you know about your 3D Mohs circle. Now the calculation that you see from the solution manual. So if I were to pick the solution manual, right, they show that I got not a clue how they get this. Okay, this is not right at all. Okay, we have to calculate where the failure is. Okay, so like what I've shown you, I think I've shown a very long example on this also, remember, right, on one of the lecture. So let's see which lecture did I show this very similar procedure. Is it 12? Or because it's quite recent, probably it's 13. Cannot be 30. Yeah, wait. Yeah, very similar to this one. Okay, in fact, this one is a true way of calculating it. Okay, so if you want to revise, okay, week 13 Thursday, you have to go through this lecture to do the last two questions. In fact, down here, I taught you how to form your shear stress, shear force, and bending moment equation. Okay, there you go. This very similar. Okay, now, I mean, it's up to you, all right, because question 6 is very similar procedure. Okay, what do you think? Should I skip or should I still do it? The procedure is exactly the same. What is the good news over here is we are given what to use. That's all. Okay, so are you all okay for me to not do question 6 or you want me to do question 6? Anyone?
Can you just do the bending moment diagram and shear force? I couldn't get them.
Oh, so you want me to do the bending moment and shear? Okay. So I will only attempt the bending moment and shear force diagram. Right. You want me to form the whole equation or just part of it?
The whole thing, please.
Then my advice for you is to look at lecture number 13 or not. I can only do 2 examples, you know. Okay, you decide. Okay.
Could you do one of the combined loading questions?
Okay. I will do this. Zai, can you tell me what issues you have with this? You cannot
I,
you cannot tell me I cannot form the equation. What issues are you facing?
like I'm just getting the wrong numbers.
What are you getting that is the wrong numbers? Can you be more
Sure.
detailed?
Yeah,
Okay.
just give me 1 second.
What are you? Because I want to do a question on combined loading also.
Yeah.
If you can be more specific, you'll be fantastic.
So I got the AY and the CY.
So that one is
And
no problem.
yeah, but then when trying to get like the ones in between to get the max,
Mm.
the V max, I couldn't get it.
Okay, so let's look at point C. Okay, let's look at point C. Right. So at point C, right, we are going to draw our free body diagram at point C. Okay, so this is not that bad. Okay, at point C. So this is point C. This is point D. And you mentioned you can find CY, yes or no? Right?
Yes,
And
yeah.
what is the value of CY if you can tell me?
I got 27.
Okay, you got 27. Right? And then down here you have 18. Right? Okay. So we are going to draw our shear force and bending moment from point C to point what? To point D. Okay. So now we are at point C, right? We are going to assume positive shear to be going up. Positive bending moment will be going in this direction. Okay. And we know the distance from here to here is equal to 3 times 12, which is equal to 36 inches. Okay. So we do static. Now, Zai, you know why this is going up and going clockwise? Are you okay with that?
Yeah.
This is because of positive shear, positive bending moment analysis from right to left. So our analysis is from right to left. Okay. So we're going to take our moment or our forces from there. So summation forces in the y direction is equal to 0. So we have VC plus by 27, right? And then we have minus 80. Okay, we have minus 18 over there. And this is equal to 0. So the shear force at point C is equal to minus 9. Okay, minus 9. So if I'm going to sketch, right? So this is our point C. This is our point D. So at point C, this is at where? Minus 9. Okay. But it's going to go up by what? Down here, it's going to go up by what? 27, right? So when it goes up by 27, minus 9 plus 27 is equal to what? 18. Do you see that? Then from here, there's no distributed load. It go horizontal. Then come to 18, it comes to what? 0. Okay. So this is for your shear force. Are you okay with that?
Yeah.
Okay. So the bending moment now is summation about moment. For example, we say in the z direction at point C is equal to 0, right? So we know that the value, I think the book does in feet, so I'm going to leave it as 3, right? So we're going to take moment over here, right? So clockwise is going to be equal to minus 18 times 3. plus, again, clockwise minus, clockwise, both are clockwise, minus, right? Moment about C is equal to 0. So moment about C is equal to minus 18 times 3. So this is equal to 18 times 3 minus 54. Okay. So if you look at the solution, right? At point C, right? At point C is equal to what? Minus 54. At point D, it should go to 0 because over here, there is no resistant moment, so moment is equal to 0. Is that okay for you?
Makes sense. Thank you.
Okay. Okay, so there. Okay, so the next request, really quick, is combined loading. Okay, combined loading, which question, please?
Question 6.
Question 6. Okay, question 6. So I'll go to
Wait, actually, could you do question 5 instead? Sorry, I changed my mind.
question 5. Okay, question 5. That's homework 8. Okay, so we are going to find the stresses at point A, element A, the 3 points element A, B, and C. So the first thing of all, when you have any of these questions, you have to verify what we are looking at. Okay, so by doing, what do I mean by that? Is we have to determine our transformation immediately. Okay, so we can call this our X and our Y and our Z. Okay. So from here, we know that the centroid relative to the element is this. Okay, this green line is the centroid for the elements. Okay. So from here, we know that the normal stress we are going to find is in the stress y direction. Okay. So it's important to sort this out now. So we know that we have Py over A, right, will induce a stress Y, plus via Mx over Ixx multiplied by Z, plus by Mz over Izz multiplied by X. Now I wrote it as plus for now. Later on, when we do the bending moment vectors, you can change plus or minus, or when we look at specific points, we know whether is it plus or minus. Okay, so for that is the general formula. And then for this case, we know we have shear. All right, we know we have shear.